The pressure, volume and temperature of an ideal gas law are related by the constant K. If the pressure decreases by 1% and the temperature increases by 2%, find the approximate change in volume. We're going to rewrite the equation in terms of V. So V is equal to KT over P. We know that delta Z equals dz dx delta x plus dz dy delta y. So in place of Z we're going to use V, in place of X we're going to use T, in place of Y we're going to use P. So that means that we can now write delta V is equal to dV dt times delta T plus dV dP times delta P. Okay, so now we need to find dV dt and dV dP. So we're going to differentiate this expression first with respect to temperature and then with respect to pressure. So with respect to temperature, it's obviously just going to be K over P. And with respect to pressure, we can say that that's P to the minus 1. So we're going to get minus 1P to the minus 2, so that dV dP is equal to minus KT over P squared. So we're going to substitute these two into this equation. So we'll get delta V is equal to Kp delta T minus Kt over P squared delta P. Now, because we've been given the data in terms of percentages, what we want is actually delta V over V. So I'm going to divide the left hand side by V, and I'm going to divide the right hand side by Kt over P, which is actually the same as multiplying it by P over Kt. So for the first term I've got a K and a P, I've got a K and a P there, so they'll cancel, giving me delta T over T. And for the second term I've got a K and a T there and a K and a T there, I've got a P there and a P squared there, so I'm going to get minus delta P over P. Now the temperature rises by 2%, so that's going to be plus 2%, and the pressure is going to decrease by 1%. So that means I'm going to have plus 2% minus 1%. So the net result of that is going to be plus 3%.